Alright, so now we're in part 2 of our video. And in part 1 we talked about how do we do, when we're given a pattern, how do we make an equation from it. Alright, now I gave you a different pattern here. And so in this pattern, we are going up by 2 in my x's, and we're going up by, sorry, that's a plus, in my y's, we're going up by 4. Okay? So now, up by 2 in x's, up by 4 in y's. How can we then figure out how much it changes? So just a reminder, your m here is the change in y over the change in x. So for here, my slope is going to be, it looks like the y changes by it goes up 4, and the x changes by going up 2. Okay? We leave the x there and the y. And then we have to figure out this b. Alright? Because I know that here, this will reduce eventually down to 2x. Alright? But how do I figure out the starting point? So how would I figure out what is, and if you remember, the b is what is y when x is 0. And kind of what I need to do here is I need to kind of create over here my own 0. I kind of need to logically go back and say, what would it be if I had a 0? So I'm going to kind of do this, and I'm creating, I have my x and my y, and what if I had a 0 there? What would the y be? Well, to get here, it would have to be that plus 2, and so this would have to be, what would I have to add 4 to get 7? And the answer is 3. Okay? So what I know now is this would be plus 3 here. So my final answer is y equals 2x plus 3. So there's always kind of a way to figure it out. We're going to have more problems like this in future chapters. So I'm going on to problem number 11, which was about solving and graphing. And the big difference here is it's not an equation, it's an inequality. The less than or equal to sign makes it an inequality. The one thing that goes on in my head when I see inequality, I'm thinking in my head, I have like this thought bubble that kind of appears in my head. And it's this, I always think of it as a red thought bubble. And what it is it's saying, watch out. All right, watch out for multiply or divide by a negative. Because I know that's a switch. It's the big switch. It switches your inequality from less than to greater than, or from greater than to less than. So as long as I have to say to myself each kind of step I do, did I multiply or divide by a negative? And if the answer is no, then I don't have to do anything. If the answer is yes, I have to do the big switch. So to solve this, I would solve it, I just have the one variable, so I would start by adding 12 to both sides. Adding 12 to both sides. So now I would have here negative 6x is less than or equal to 6. I added a positive, so I didn't do anything with multiplying or dividing. So now what I would need to do to both sides is I'd need to divide by a negative 6, and that's where my bubble comes in. I'm dividing by a negative. Dividing by a negative means the big switch occurs. So now I'm going to have greater than or equal to. So this answer here would be a negative 1. This answer would be just the positive x. So my answer here in an inequality is x is greater than or equal to negative 1. Then we also have the problem of how do I show that on a number line? Okay, so to show it on a number line, I'd have to kind of first show where is negative 1. So I'd show it by kind of showing a few numbers around it. And then I have to say to myself, okay, I'm here, my value could be negative 1, or it could be the numbers that are greater than negative 1. So I just kind of have to shade in all the numbers that are greater than negative 1. But I have to have a way that I show that it could be negative 1. The way I show that it could be negative 1, in that little circle, I have a filled in circle. Okay? In number 12, we have a way that it's not, it couldn't be the actual answer, so I'm going to show what the difference is. So the filled in circle is what happens because of this or equal to sign here. That's why we have the filled in circle. And I'm going to go through an example here in 12 of what do we do if we don't have an or equal to sign. So let's look at 12 here now. So now in 12, I'm looking at this and I say, okay, we have a fraction. We don't like fractions. We like to get rid of them. So to get rid of them, if you remember, fractions are like dividing by 4. I'm going to multiply each and every term by 4. So I indicated that somehow. 4 times 8 is 32. Multiplying by a positive does not switch my inequality. Reduce here, and so I just have 3x, and then I have plus 8. Okay. Now I need to just solve it. I got rid of my fraction. I'd subtract 8 from both sides. All right, now I have that 3x's is less than 24. Divide both sides by 3, x would be less than 8. And I'm reading it backwards. 8 is greater than x. I usually like to read my variable first, so I'll usually switch it around, and I like to just say what happens with my x, or what's the values of my x. It helps me to understand it. Not in saying x greater than 8, it might be a little hard to kind of conceptualize. So now I know that x has to be less than 8. So what I would do is I'd put an 8 here, 7 would be on one side, 9 would be on the other side. So we kind of have an idea of where we are in the number line. And then I would put an open circle on my 8, and the numbers less than 8 I would shade. And in this case, because I don't have the or equal to, that little half equal sign underneath the greater than or less than symbol, I leave it an open circle. So I'm going to leave it nice and open there, and that's the way that we indicate that it's just a less than, not a less than or equal to. So now, next problem here, we have inequalities where it's between two values. So 2x minus 3 is between the 11 and between the 3. So what we're going to do to solve it, a lot like what we do up here, we want to get the x all by itself. I want to know what x is between, not just what 2x plus 3. So I'm going to start by saying I need to get rid of the 3. But what you do is you subtract 3 on all sides of your inequalities. So not just on the one side or the other. So now I have 0 here is less than or equal to 2x is less than or equal to 8. So now I know that 2x's is in between 8 and 0. Now to figure out what just x is in between, I'm going to divide each one by 2. So x alone is in between 4 and 0. Okay? So that's what we have x between. So on my graph, I'm going to have show here where is 0, 1, 2, 3, 4, 4, because we're in between those. You might even want to put in a -1 and a 5, just so you kind of know where you are on your graph. And we're talking about in between those. So 0 here, our value x could be between 0 and 4, and it could be those actual values because we have or equal to on either one of those, and we just shade in between those. So that's how it shows that we can be any little thing in between those two values. So number 14 here says, now the cost of repairing your car is $240. The cost of labor is $45 per hour. How many are the most hours so that the total cost of repairs is less than your budget of $430? Okay? So right away we know parts. Parts are going to be this $240. That's like the non-argue with it part. That's non-flexible. What is flexible is how many hours you work on the car. Sorta. Because you have to get the darn thing fixed, but that's what you can say to someone saying, well, if it's going to take more than this hours, I just can't afford it. Because we know this value here, how much the total cost of repairing the car has to be lower than $430. All right, because we know we have $430, and so we know we're going to have to get it lower than that. Okay, so we have an inequality to solve. We would subtract 240 from both sides. Okay, so we do that, 430 minus 240. I got 190 for an answer here, less than or equal to 45. I'm going to divide, both sides by 45. Oops, I did this wrong on my calculator. 190 divided by 45. I got 4.22. So the number of hours has to be less than 4.22. So I'd say to the person, look, if this is going to take more than 4 hours, I need to know now because I know how much is in my bank account and I know what I can and can't afford. And so I have to decide, is it worth it for me to fix this car? So I have to say if it's going to be more than 4 hours, it's not going to happen. And so that's going to be a really important thing to be able to solve. The next type of problem we have are absolute value problems. Absolute value is kind of like, I see this as a doorway. And when you walk through the doorway every day when you come into class, you're going to be happy, no matter what. If you're already happy, before you walk through the door, you're still happy. But if you're walking through the doorway and you're grumpy, but you come through the door, and you're going to be happy. So whether you're negative and you come through, you're going to be a positive person, or if you're already positive and you came through, you're still positive. Kind of what we're talking about here. But the way that we solve it is, it depends on what we started with. So you have to say there was two options to solve this. Either when we started, it was already positive, and so it really didn't matter that we took the absolute value and we got a positive answers. Or when we started, it was negative, and I took the absolute value and it became a positive. So in absolute values, you look at two scenarios. Then you solve these. Oops, sorry, minus 4, minus 4. 2y would equal 12, y would equal 6. Or minus 4 and minus 4. 2y would equal negative 20 because I subtracted 4 from both sides. Y would equal negative 10. So in absolute value problems, we actually get two answers. When we graph it, and we'll do a lot of graphing in pre-calc, the answers actually look like that. They look like little V's. Okay, so your graphs of absolute values look like this, your little V's. And so there's two answers usually for every x value. There's going to be two different answers there. So it just depends on what we're working with. Or for every y value, sorry, there's going to be there's two y values for every x value. All right, let's look at another one. So we're going to solve this problem here. We have to solve this absolute value problem. I like this problem. We're looking at two options. Now the big thing that's changed here is now we have an inequality. And what an inequality does, I gotta extend this page. The inequality kind of ramps it up. It kind of says, okay, we've got a little bit more we have to work on here. Oh, darn it, I don't know why that's doing that. Let's see. What I got, there we go. Sorry guys, I don't know why. My computer's being stinky. All right, so you have two options here. One option, exactly the way it's printed. 3/4 y plus 4 is less than or equal to 6. All right, so in other words, what was inside of your absolute value system, notation, sorry, was positive to begin with. The other option was it was negative to begin with. Now, if it was negative, at some point we would have had to divide or multiply by a negative, and so at some point we would have had to switch this. And so if that was a negative to begin with, it's actually, you switch it. So here, on this side, I call this as is. And this one I do switch. You have to switch and switch. You have to switch two things. You switch your inequality here, and we're switching, inequality, and you're going to switch your positive to a negative. So now we're solving this, and I'd start solving this by multiplying each and every term by 4, and that's going to get rid of my denominator of 4. And so we'd have an answer here of 3y plus 16 less than or equal to 24. I'm going to subtract 16 from both sides. I kind of do this nice and small here. 3y is less than or equal to 8 is what we'd have left. And you're going to have a fraction, 8/3. That's all right. Fractions are fine. We like our fractions. Here, we're going to again multiply both terms by 4. So now we're going to have these cancel out. 3y plus 16 greater than or equal to negative 24. So now I'm going to subtract 16 from both sides. And now 3y is going to be greater than or equal to negative 40. And y would be greater than or equal to negative 40/3. Now some people would say, well, you have a negative there. Doesn't that change your switch your inequality? No, I didn't divide by a negative. What I divided by was actually a positive. And it's only when you divide by the value you divide by is a negative that we're going to have the big switch that's involved. So now let's look at this problem. Before I can do kind of the big switch here, I have to first divide both sides by 3. So before I can look at these as two options, I had to say, what was that absolute value all by itself? I have to isolate the absolute value first. Then I can look at the two options and solve it. And you can see here the solution to this is that either y is greater than 8 or y is less than 0. Okay? I think that might be it. That's it for this chapter.